Record. Okay. Um, so what we're going to be doing, guys, it's a lot the same. Like I'm going to keep you guys on formative. So, we're going to go into the next unit. The one thing though, I like we weren't able to do the exam for the unit 7 there, right? But we're not going to be able to do it. So what I do want you guys to make sure that you do, and I'm going to be giving you guys a mark. You know that last assignment that you guys were working on? I want you to do that one, and that will be like a main part of your mark. And if anybody's not happy with how they did on that one, you know what I'll do? Can you, if you're not happy and you'd like to do it again, can you send me an email and I'll reset it for you so that you can try it again? You can try to get a better mark on it if you like, because you didn't really know that was going to be like the main assessment for that unit, right? But if you haven't finished that, that's going to be step number 1 for you guys to finish that. So I see that like there's a lot of people that are completed half of it now or something like that, right? But let's say even if you've completed half of it and you want to start over, then let's just do that. We'll start right over. Just give me an email and I'll reset it for you. Okay.
Okay.
The next one, your flag projects that you guys were working on. I marked the ones that I had. If I didn't have yours, then I'm not going to mark it. But what I'm going to do with that is, if you, for the most part, people did pretty well. Like it's kind of a good little project. But if you haven't done it, you don't have to do it. But if you want to, then it'll make your mark better probably. So if you want to still do it, if I don't have it and mark it, and send me a picture of it, then I can still mark it that way and I can give you guys a mark in that one. But if you don't do it, I'm just going to go omit. So you just won't have a mark forward at all. Does that make sense? Everyone give me a thumbs up if you understand that one. All right, good. Okay, so next one. We're going to start on the next unit. So you'll see over here. So oh, sorry, you're on Math NC. So we're going to start a new unit. So you've got the Unit 8 notes, and I've got the 8.1 formative, like the links for them right now, so you guys can click into those. It's the same as it is before, and everything is still on my website too, right? So Jocelyn asked me if I can put the whole Chapter 8 textbook on the website, so the whole thing's on my website now too if you want to see the whole unit. You can access the notes. So when you guys go into the notes here, it looks something like this, right? So, how's it going? You want to say hi?
I'm laughing. That's how this setup is now.
Oh yeah. Oh yeah. So yeah. So when you guys get into the notes here, was anybody able to print them? It's probably going to be a little easier, especially for this unit, if you're able to print these notes. If not, it's fine. You'll probably just have to like draw the pictures and kind of work on it with us, like just on a piece of paper or in your notes, right? So you know what I'll do for you guys though for this one, just so we don't have to go over it again, is I'm going to go over this Chapter 8, just a few questions in it so you can get started on the formative if you want. The other one though is if this doesn't work for you, there's actually a video in that formative as well and on my website that goes through the same thing. So you'll have both of those. And then if you want to see this again, like Hazlitt was saying, like I'm gonna put this video in that archived spot so you'll be able to access it later too, okay? So yeah, so let's go through this. Can you guys grab a sheet of paper if you don't have the notes, or if you printed off the notes, can you grab that? You might be looking at the top of my head for a while here. I'm not big on this this Zoom thing because it's showing how I'm going bald. Did you have a question, William?
Am I going back to my old stuff, or I'm gonna just continue with you guys?
Yeah, you know what? I'm gonna get you to do the transformation stuff I was talking about there. But can you stay on the line after we're done? I'm gonna give you a bit more direction on what you're doing there. But yeah, you'll be doing some other stuff. Yeah, cool. Thanks. No. Okay. All right. So we're starting circle geometry. 8.1, yada yada yada. So what this is, the study guide, this is going to be a really handy sheet for you guys because it's the whole unit in a nutshell. It's like a 1-page version of everything you need to know on this unit. So we're doing this this first part in this lesson. Okay. So what this unit is on, guys, by the way, too, is it's on circles and just how we can do a bit of like math to figure some things out, like with trigonometry combined with circles, to find out some, I think, cool problems. But anyway, so, all right, so we got this first part says a line that intersects a circle at only one point is referred to as a tangent. So this is going to be a like an important point here. So what a tangent line is if you have a circle, can you see that like this line right here, right? That goes from there to there. That line has like the same distance from here to here as it does from here to here, right? Like, and we call that line tangent. You could make that line anywhere you wanted, right? Like you can make one here too, right? Like that could also be considered a tangent line, right? The word tangent, yeah, have you guys ever heard anyone say like, you know, someone's gone off on a tangent, right? Well, what that means is like, you can think about it this way, is like if somebody was going, you know, around in a circle, right? They were going around in a circle, right? Like that. Going off in a tangent means that you kind of stopped going in a circle. You started going off into a straight line. That's like going off into off on a tangent, all right? You're kind of not following the normal path. You've kind of left the path, right? So that's what it means when someone says they've gone off on a tangent. It actually means the same thing. So anyway, some different things happen with this, right? Is that if you have a tangent line, you can see what ends up happening is that if I have a circle and there's the center of my circle, that you're going to have a line that would extend. This would just be the radius of the circle, right? Well, look what happens. That turns into a 90-degree angle, right? That little box there means that's a 90-degree angle right there. That's going to be really important, right? So that's the first thing. And yeah, let's move on to the next one here. The other key bit of information, so it's a good thing we know about Pythagorean's theorem because we're going to be using that now too, is that look at what else can happen, right? That if I have this tangent line, right, this one here, that makes a 90-degree angle. Well, if I take the end, right, from like one point to the center of that circle, right, and draw a line from there to there, do you guys see that I've ended up making a right angle triangle out of that? Right? And as soon as I have a right angle triangle, I know I can do some trigonometry with it, right? We can use our a squared plus b squared is equal to c, a squared plus b squared is equal to c squared stuff, right? So that's kind of where we're going here. The other thing that we know, right, is that let's say we did this and a question was saying that we know that this thing here is 30 degrees. Does anybody feel like they could figure out what this angle would be? If I knew that that one there was 30 degrees, what would that angle be? Can I get you guys just to think about that for a second or write it down? Like, what do you try to see if you can come up with a number there? Here, you know what? I'm going to pause the recording here so we're not recording back on. Okay, so yeah, it would be 60. And how do we know that? Well, remember, so this is 90 degrees, right? So if that's 90 degrees and that's 30 degrees, then the key bit of information here is that all of the angles in a triangle always add up to 180 degrees, right? So if I go, well, you can go 30 plus 90 is 120, right? And then I need 60 more degrees to get to 180, right? Or the other thing, you could do it this way too and say, okay, 180, and then just subtract these two angles, right? 180 minus 90 is 90, minus 30 is 60, right? So you're left with 60 degrees there. So yeah, it's good. The biggest part here is going to be actually like noticing what to do. Like I think you guys have all the skills already to do these questions. You just have to like recognize it when you see it. So all right, so that's it. Now let's just talk about what the way this looks right now, because you guys probably haven't seen like, you know, this symbol and that symbol and the way they look, but it's not too bad. So what this is saying in English here, this part here says in, and then that's a triangle, right? So it's saying in triangle ABO. Okay, well, what that means is they're just talking about in triangle from A to B to O, right? It's the triangle that's made out of those things, right? So that's the triangle. It says, now this part will be a little bit different. It says angle AOB is 63 degrees. So what that means is that if I started at A, went to O, and then to B, right? Angle AOB, that little symbol means angle. That's 63 degrees. So just know this, what happens here is the angle it's talking about is the middle one. It's the middle angle that is going to be 60 degrees. It's the one that's on O. So so it says now determine angle ABO. Okay, well, what that means, the middle one, right? It's the middle one it's talking about. It's asking, what is that angle? Does that make sense? Yeah. Okay. So how would we do that? Well, to do that, you'd say, well, you can look at all this. It's written a little bit funny. I'll walk through like what it all means. It says we know that all angles must add up to 180. So what we were just saying, right? And it says since angle OAB, so OAB, they're talking about this angle there, right, is 90 degrees, and angle AOB, so this angle is 63 degrees. We can find angle ABO, which is this angle, by subtracting 90 and 63 from 180. So that's just exactly what I did up top, right? And we'd end up getting 27 degrees there. How you guys doing? Can you give me a thumbs up or tell me in the chat if that is all making sense? Okay, perfect. Okay, so now this one, right? They've given us the same type of thing where I can see, okay, I can even see that this triangle here, right, is a right angle triangle. Can you guys tell that, there is my right angle, right, on that side, and this would be my hypotenuse, right? So there is a leg and there is a leg, and I got my hypotenuse there. The whole triangle has been tilted on its side, but that is a right angle triangle. And they've given me that this length is 20 and this length is 15. Okay, well, I could label this with A, B, and C, right? That, if this was side A, and let's say this was side B, and this is side C, right? Because the hypotenuse is always C, right? Then we can say, okay, well, normally our equation is A squared plus B squared is equal to C squared. But we've done this a ton now, right? You guys know how this changes, right? I have C, I already have C, and I have B, and I'm looking for A. So the way this should be changed is it's A squared is equal to C squared minus B squared, right? And then we can just fill our numbers in like we did up here, right? So I'll leave that to you guys. We've done a ton of Pythagorean theorems, so I think you guys will be all right there. Okay, so this one to be something very similar. An airplane is cruising at an altitude of, so altitude now means how high off the ground you are. So an altitude of 9,000 meters above the Earth's surface. A cross section of the Earth reveals a circle with a radius of approximately 6,400, and then be careful, kilometers. And it says, how far is the plane from point H? All right, so let's do this one. So in this case, it's telling us that, so if this is the center of the Earth, from there to there, like the radius of the Earth is 6,400 kilometers, right? All right, so what I'm gonna wanna do here though, first, do you guys notice I've got kilometers and I've got meters? I need them to be in the same units. So what I'm gonna do here, you know what I'm gonna do? I'm actually gonna do this in kilometers. I could do it in meters or kilometers. I think it'll be a little bit nicer, smaller numbers if I keep it in kilometers. So let's actually change this 9,000 meters. Does anybody know how many kilometers 9,000 meters is? Does anybody know how many meters 1 kilometer is? I can hear people mouthing it. Okay, yeah, so good. Yeah, it's 1,000, right? There's 1,000 meters in 1 kilometer. Okay, so then this would end up being the same thing as 9 kilometers, right? Okay, so if that's the case, then the distance from here to here, well, if this is 6,400 kilometers from there to there, and this is 9 kilometers from there to there, then really, well, what we would do here, you'd add those two things, right? So we can do that and say, well, this then would be 6,409 kilometers. Makes you realize how big the Earth actually is, right? When you're 9,000 meters in the air, that didn't really make much of a difference there. Okay, so now that's one side of our triangle, right? You can see this is our right angle triangle, and it's asking how far is the plane from point H, right? It's asking how far is this from here to here. It's asking for this distance. I've only got one side of my triangle, right? I would sure like to have that side of my triangle. Here, let's clean this up. I'd sure like to have this side of my triangle, right? Because then if I know two sides of my triangle, I can find this side. Anybody have any ideas? Can you tell me in the chat? Anybody know what would that side of that triangle be? So, yeah, tell me in the chat. Oh, Blaine and Caprice got it. Sierra got it. Peyton got it. Nice. Yeah, it is. You can see from the picture, right, that this from here to here, right, is 6,400 kilometers. Well, that's the radius of the circle right there, right? Well, this is also the radius of the circle, right? So there's a bit like you have to be able to kind of look at it and see that that's going on there, right? So that would also be 6,400 kilometers, right? So that's also 6,400, well, not squared, just kilometers. Oh, I'm freezing. Oh, there we go. Okay. So what we got going on here, I'm just going to redraw that triangle for a second. So we've got 6,400 kilometers, and we said that the hypotenuse, that's not the same triangle. Sorry, guys. Do you guys probably see me glitching all over the place too, eh? I might need to do something different next time. We'll see. Okay. Okay, so what we're going to do here is it's going to be this squared minus this squared gives us this squared, right? So it's going to be 6,409 squared minus 6,400 squared. And we'll say that's A over here, right? So we'll say like A squared was equal to that. So A squared is equal to, and then I'm just doing this on my calculator here. 6,409 squared minus 6,400 squared equals that. And then, so I get 1,15281. And then very last step, I hope everyone remembers square root, right? So square root both of those. So A is equal to the square root of that. So we end up getting 339.5, and then remember we were in kilometers. So that's how far away we were, right? All right. So you know what, guys? That's it. So I got to let you guys go here because I got another class coming in. Can you guys go to the formative and then what's on the schedule? What do they have you guys for? Here. Sorry, I'm going to turn the